For today's lesson preview, you would write the formula for the surface area of a cylinder. So if you take your cylinder and you stretch it out, you're going to get the shape of a rectangle where one side has a length of h and the other side is actually the circumference of your circle. So that'll be 2 pi r. And then when you find the area, your surface area, your area will be 2 pi r multiplied by h. Now, as a very specific problem, you're told that the radius is 3. So the area is going to be 2 pi r is going to be replaced with the 3, and then you're going to multiply by h. So we have 6h pi as the area when the radius is 3. Now, the reason this formula becomes important, we're going to be looking for the surface area of regions that are going to be rotated about either the x-axis or the delta, either the x-axis or the y-axis. So the surface area is going to be found the same way. We're going to find 2 pi r h within our problem, and of course it's going to be some sort of integration involved. Now, as we look at this picture, you can see that the height is not the same all the way around. It's going to be different depending on the x value that we're chopping along the axis for. So if we rotate our arc L about, an arc, so that sounds like arc length. So L is actually going to be found using the arc length, and you know that the arc length is the square root of 1 plus, cutting on the x-axis, so that's going to be dy dx, and that quantity is squared. Now, we talked earlier that the arc length is dimensionless unless you put in dx. So the radius from the axis of revolution is going to change depending on where we chop, and the integral to find the surface area for that region that's being revolved about the x-axis is going to be 2 pi multiplied by the radius, chopping on the x-axis, so the radius has to be with respect to x, multiplied by the arc length, so this is the height. When we think about 2 pi rh, we will have 1 plus, here's your dy dx, quantity squared multiplied by dx. Now, we're using x values, so we're going to integrate from a to b. Let's check out the units to make certain that the units are sensible for this problem. An area is supposed to be a figure that has length and width. We have the radius, that's going to be measured in some sort of length. We have the arc length, which is another length because it includes the dx. So we are going to be measuring in units squared whenever we use this formula. So it's units squared because it's an area. Now, if we revolve about the y-axis, the formula is going to be very similar. Your surface area with respect to y is going to be 2 pi integral from c to d, the radius from the axis of revolution with respect to y, and then the square root of 1 plus your dx dy, quantity squared dy. So if you cut it on the y-axis, use y values. If you're cutting on the x-axis, use your x values. For example 1, we have y equals the square root of 4 minus x squared. At this point, you should recognize that that is one part of a circle. And again, when you're working on a problem, you should always draw the picture. So when we draw our square root 4 minus x squared, we're going to first go from negative 2 to 2, but this particular picture is only going to be used from negative 1 to 1. So the region that is spinning is going to be between negative 1 and 1. It'll be spinning on our x-axis so that we can get an idea of what's happening with our picture. All right, now once we have a good graph, think about what your surface area formula is. You know that the surface area is using the big idea 2 pi r h, where h is going to be arc length. So in our problem, the surface area is going to be equal to the 2 pi the x values are traveling between -1 and 1. The radius, let's draw that in. Now, the radius is drawn from where we're spinning to the outer edge. That is a length of y. But since we're cutting on the x-axis, we're going to fill in what y equals. So the radius is the square root of 4 minus x squared. And now we need the arc length. The arc length is the square root of 1 plus the derivative squared. So I need the derivative of y. Now, as you find that derivative with respect to x, please remember you're going to have to use your chain rule. So this is our formula for surface area. All right, then let's go find y prime. Y prime, using your chain rules, 1/2, keep the inside. Here's your 4 minus x squared to the -1/2 multiplied by our -2x. Simplify the problem, and we now have -x over the square root of 4 minus x squared. All right, so once we have that, we will square it, substitute it in, and our surface area is 2 pi, the integral from -1 to 1, multiplying 4 minus x squared, add 1 to this function, and simplify. Once we simplify, we're going to end up with 2 over the square root of 4 minus x squared dx. And that should be very easy for you to integrate. Looking at question number 2. We have the arc of your parabolic function, but we're only going to go from 1, 1 to 2, 4. Again, start by drawing a picture. The pictures are important. We have our parabolic function. Fill it in here. We're only interested from 1, 1 all the way to 2, 4. So the piece we're looking at is right here. And we're going to spin about the x-axis or spin about the y-axis. So I actually want to show you both ways. I'm going to show you the y spinning, and you're going to figure out the surface area with respect to x. So I'll start with y. When we're spinning about the y-axis, again, surface area uses the big idea, 2 pi r h. The radius in this case is going to be coming across, and that length is going to be equal to x. But what does x equal? X in this problem is equal to the square root of y. It's actually plus or minus the square root of y, but I'm only interested in the positive part because we are going between 1 and 4 for our y values. So the surface area is equal to 2 pi, the integral from 1 to 4. Again, once we have 1 to 4, the radius we know is going to be the square root of y, so write y to the 1/2. Once we have the y to the 1/2, we need to multiply by the arc length. So the arc length is going to be the square root of 1 plus, then the derivative. So x prime in this problem is 1/2 y to the -1/2, which is 1 over 2 root y. Square that, that will give us 1 over 4y dy. And then we will simplify our problem and integrate. So we have 2 pi from 1 to 4, y to the 1/2. Now when we simplify, we're going to rewrite this as 4y plus 1 divided by 4y. But when we divide by 4y, that's the same thing as dividing by 2 square root y. And lovely algebra happens. Oops, don't forget your dy. In order to integrate this problem, your square root y's will cancel. You're going to use u sub, where u is equal to 4y plus 1. And your du is 4 dy. And then you'll be able to integrate the rest of the problem. All right, so here we have our functions here. If you are looking for the surface area and you are cutting along the x-axis, it's going to be 2 pi, and here's your r. This part is your h, but that is the arc length. If we're going around the y-axis, 2 pi. This is your radius again as we go to the y-axis, and arc length definition that we worked with last class. Please remember that you are to look at example 2 with respect to x, and then go ahead and complete your practice.